So in this video, we will be discussing the problem linked list remove. The problem is, given a linked list and an integer x, we have to do what? We have to remove the node in the linked list whose data is x. So actually, in a linked list, we have to search a node which is having the value data x and then delete it from that particular linked list. You can assume all nodes in the linked list to be unique. That is, there will be exactly one node with the data x. So in the entire linked list, it is given in the question itself that it is always necessary that the data which you want to remove is present, and it is also present only once. It is not present multiple number of times. So now let's read the remaining problem statement. Note that input and output will be handled by a main method behind the scenes. You do not have to implement it or write any input and output. So actually you will be given a linked list already created. You do not have to create it. You do not have to write the input and output. You will only be required to implement the remove function, which is defined and which is about to return the answer based on the return type, if it is having any. But based on different languages, you will have different kind of return types. In the Java, it is not having any return type. It might be any header node which is about to be returned in some other language. What we have to do is we have to be using the structure of the linked list, which is given as a reference in the code itself. That is a list node having two things. First property is nothing but the value, integer value, val, and second property will be the address of the next node, that is list node next. And one constructor will be given to create nodes if you want. Although in this question we do not want to create nodes, we only want to delete them. So structure of the linked list we have already discussed. What will be the input format? We do not have to take care about it. There will be certain number of nodes, and all the number of nodes will be having certain values, and the integer target x will be given, and we have to print the linked list after removing it. Although we do not have to do it, we only have to delete the node which we want to, in which is actually asked in the question. So if let's say there are 5 nodes, 1, 2, 3, 4, 5, and the node which we want to delete is having the value 2. So after deleting the node with value 2, the remaining linked list will look like 1, 3, 4, 5. After 2 getting deleted, 4 nodes will remain. So what can be other scenarios, or what can be the different possible certain test cases assigned? So let me just add a new, you can say a new linked list. Let me create a new linked list. First node, second node, third node, fourth node, fifth node. Let's take the data 10, 20, and so on. 10, 20, 30, 40, 50 in each of these linked lists nodes, and also the next pointer is obviously pointing to the next address, next node's address. So addresses of these nodes can be random. I am not writing the addresses because it, even if you want to write it, it will be completely hypothetical. So if this is the linked list, obviously we have to represent the linked list using a head node, or you can say the first node of the linked list. So first node of the linked list is nothing but the node with value 10. And let's say we want to remove the node with value 20. So if we need to remove 20, what should be the linked list after removal of 20? After removal of 20, 10, then 30, then 40, then 50. This should be the remaining linked list. What about removing the node with value 30? If I want to remove value 30, then after deleting 30, the remaining linked list will be 10, 20, 40, 50. Similarly, after removing 40, remaining linked list will be 10, 20, 30, 50. What about removing 50? Obviously, if 50 is removed, that is the last node. Linked list will be 10, 20, 30, 40. And same goes for the first node. If I want to remove 10, then remaining linked list will be 20, 30, 40, 50. But in this case, head will be updated, because now in this case, head will not be 10 anymore. It will be actually 20, the first node of the linked list. So we have to take care about two types of scenarios actually. That is, first scenario where we have to remove a non-head node. Example, can we remove a 40, where we are deleting a node which is not the head. So deleting a non-head node can be one certain scenario. What about the other scenario? Obviously, we are deleting the head node. So removing the head node, that is removing 10 in this case. There can be other certain scenarios, like there can be remove of 60. But in the problem statement itself, it is mentioned that the node which you want to remove will be always present exactly once. So this type of scenario will not be occurring in this particular question, but it might be there that you are asked to remove a node which is not present at all. So in this case, you have to ignore it. Or similarly, if you are asked to remove a node, let's say from a empty linked list. So if let's say there was no linked list, in that case head would have point to null. So from that linked list, if you are asked to remove anything, like value can be anything in that case. So again, you should not be able to remove anything because empty linked list does not have any node at all. So how can you handle the scenario when there is nothing in the linked list? If you would have been required to handle it, you can check whether the head is null or not. If head is null, obviously we cannot delete any node. We should directly return from the function. If we are asked a return type, we will be returning null pointer or the null node. And if we are asked void return type, then we will simply return. That is, if head is null, do not do any traversal, directly return from the function. What if we want to delete something but it is not present? How we will get to know if it is not present? Only after the traversal. So once we have done the traversal, complete traversal, and we are not able to search the node, we will say again return basically the same linked list. So in this case, we have to return the same linked list. What do you mean by the same linked list? We have to return the same header node if we want to return something. If we only want to return, we can just simply say that no deletion should happen. But in these two scenarios, we have to handle like properly. So how we can delete the head node first of all? If I wanted to delete 10, how can this linked list having 5 nodes become a linked list having these 4 nodes with the 20 as the new head node? We can simply say that if we want to delete the first ever node, if we want to deallocate the memory, then that is a different thing. In different languages, the deallocation of memory is different. Like you can use delete function in C++ or free function in actually free operator or free function in C language. There can be different functions in different languages. In Java, it is automatic garbage collection, so you do not have to do anything. What we are only about to do currently will be ignoring the memory allocation, memory deallocation actually. We will be only focusing on how we can remove it from the linked list. So if we want to delete from the linked list 10, we can say that simply move the head to the next node. And how can I move the head to the next node? I can make head should point to head's next node. That is head is equals to head dot next. So if we want to delete the starting node, a simple one updation will require, and that is head is equals to head dot next, and then simply return. So this is the simple updation. But the scenario, the biggest code will be for the scenario when the node to be deleted is non-head node and it is existing, it is present. So first of all, in order to delete that node, we have to search for it. So we can say, let's have a current pointer in order to search for it. Because if we are updating the head node, linked list will also be actually getting deleted, because moving the head further, you will be getting lost the value 10. So what we can say, let's maintain a current pointer. Initially, it will start from the head node itself in order to traverse in the linked list. And how I can traverse in the linked list? We can easily say that if I want to go to the next node, there is no indexing in linked list. There is a next pointer. So I can say current will make and go to current dot next. Is the current node value equal to what we want to delete? No, it is not 40. So current is equals to current dot next. Is 30 what we want to delete? No. So current is equals to current dot next. Is a 40 what we need to delete? Yes, surely it is. But if I am only having the current node which I want to delete, can I delete 40 directly? Will I be able to delete 40? Actually, no. Because if we want to delete 40, what we should do? 10 should point to 20, 20 should point to 30. No changes in that. But the 30 node should point to 50 node. 30 node should point to 50 node, so that after 30, next node should be 50 and not 40, so that 40 will be deleted. So 10, 20, 30, 50, this should be the updations. This should be the chaining. So in order to do that, in order to make the 30 nodes next node as 50, we need the pointer at 30. We need the previous node pointer. So if we need the previous node pointer, we cannot only maintain a current pointer. We also have to maintain a previous pointer. So let's start the dry run again. We will be saying initially what is the previous pointer for the head node? Previous pointer for the head node can be null because there is nothing before the head node. There can be null. Similarly, after the last node, there is null. Same is the previous node for the head node. And now start the logic. That is, before making current is equals to current dot next, make the previous come at the current, and then make the current is equals to current dot next. That is, then make it go to the next node, so that we are able to maintain the previous node. Also, we are able to maintain 2 pointers. Again, ask, is current equal to what we need to delete? No. So first make previous go to current, then make the current go to the current dot next. Then make the current is equals to current dot next. Similarly, previous is equals to current, current is equals to current dot next. And as soon as the current pointer reaches a node having value 40, that is what we need to delete. What we can say, now we have the previous node, the data 30. We want to delete, we want to delete 40. What should we do? We can make the previous node's next node point to 50. So how can I make the previous node's next node point to 50? How can I make 30's next point to 50? I can say this is previous, this is current. What is this? This is current dot next, this is current dot next. So previous, your next node should be what? Previous, your next node should be current's next, that is 50. So previous next should be updated to previous next, that is previous dot next, should be updated to current node's next node, that is 50. So in this, what will happen? 30, your next node will become 50. And then we can just break out. We can just say that 40 is deleted because no one is pointing to 40. All the 40 might be pointing to 50 nodes, but no one is pointing to 40 because 30 is now pointing to the node with the value 50. So 40 is actually, you can say, deleted from the linked list. That's it. So this updation we need to do once we find out the current pointer with the target node. And we also have to maintain previous pointer. So we will require traversal in order to search, a linear search kind of thing. And then we need to maintain basically 2 pointers to do the traversal along with making the updation, that is previous dot next is equals to current dot next. So this is the milestone number 2, which we have discussed, that how we are going to come up to the approach. It is a simple traversal algorithm which we are facing currently with 2 scenarios. Now let's code the instruction manual. Now let's write the instruction manual actually. So we will not be changing the head pointer and the constructor solution. That is where the head is initialized to null. We will be first of all checking for the corner case. What are the corner cases possible? If linked list is empty, that is if head is null, we cannot delete anything. We should return. So we should in this case return from the function, because currently the return type is void. We will only return. Next, if it is not a corner case, then we obviously have to basically run a 2 pointer technique. So we will make 2 node variables, two list node variables, previous and current, initially set to what? Initially where they were starting the traversal, initially set as null because the head node's previous was null and head node respectively. So initially the current will be starting from head. So now after initializing both the pointers, we will say that do the traversal till the point, run a while loop till the point that we are able to serve the target node. And in this question, obviously target node will be present. So we can say current value is not equal to target. Till that point, we will run the loop. Or we can also say that in every case, in the case where we have to remove 60, where we will reach, we will say once the current pointer becomes 50, it is also not equal to 60. Once it will become to 50 dot next, that is null. Now we have completed the traversal. And if we have completed the traversal, we should stop. So run the loop till the current pointer, current node is not null. It is not reaching to a null node. And if it is the case, what should we do? Check if the current node is nothing but having data, if current node's data, that is node dot data or current dot data, or actually val, is equal to target, that is x. If it is, then we have to delete it. How we can delete it? By using the previous pointer, that is previous nodes next pointer should be updated to what? Updated to current nodes next node, that is previous dot next is equals to current dot next. And if we are able to delete it, we will just break out that we are done. Otherwise, if we are not able to search, then we will move the pointers. How we will move the 2 pointers? Previous will become current will become current dot next. This is how 2 pointers were moving. So update previous as current and current as current dot next, currents dot next. Finally, if we are able to delete, then we do not have to return in the case of Java. So we will not be returning anything. In any other language, you have to do just return the same head. But one more corner case that we have discussed. What is that? If we are asked to delete the head node itself, remove 10 itself. So how we can delete 10 itself? We can say head is equals to head dot next. So one more corner case can be corner case number 2, it should not be before the head is null, because you can only go to next node, or you can only compare the data if head exists. So if head data, head's value is nothing but equal to x, then delete the head node itself by doing what? Then make the, we have to do what? Make the head is equal to head dot next. So head will become heads next, and then just return, and then return. So this is the second corner case we have to handle. So two corner cases and one simple case where we have to first search and then delete. So what will be the time complexity in order to do this? See, if we are handling a case where we want to delete the head node, obviously it is constant time if we want to delete head node. But if we want to delete a node which we do not know where it is, we have to search for it. And worst case searching can go linear because there are n nodes. So linear time for worst case, constant time for the best case. And also for the case where the target is not present, it will also go linear because target is not present at all. So in worst case, it will be linear in nature. What about space? Are we using any extra space? No, actually constant extra space. We are using the same linked list and deleting a node in that same linked list. We are only maintaining two pointers, previous pointer and current pointer, 8 bytes, 8 bytes, or 4 bytes, 4 bytes, whatever language you are using. So no extra space as such. Now we will be doing the fourth milestone, that is doing the instruction manual code expansion. So first of all, we have to handle the corner case that if the head node is a null node, there is nothing to be deleted. So if there is nothing to be deleted, we can say shortly return. If head itself is the target node, if head dot val is equals to x, then in that case, what should we do? We should do two things. First of all, delete the head node. How we can delete the head node? By making head is equals to head dot next. So head will become head dot next. And second thing, since deletion is done, so we can return, no need to run the remaining code. Otherwise, now we have to do the traversals using two pointers. So list node, we have to maintain a previous pointer as discussed in the approach video, because if we want to delete a node, we need the previous node to it so that it can point to the current next. So previous initially will be null, current initially will be equal to head itself. And we will be starting the traversal till the point the current node does not reach as null, because if current reaches null, there is no more node to be searched, or you can say target is not present. Although in this question, target will always be present. So how to check if current node is equal to x? We can say current node's data. If current dot val is equal to x, we have to delete the current node. So how we can delete the current node? We can say previous next, your next should basically point to current's next. That is in the example, 30's next should point to 50 actually, because 40 is to be deleted. And then we can break out if you wish. If you want to continue, you can just continue the loop. But currently we were breaking out. And otherwise, what we have to do? Otherwise, we have to update the previous as current as current dot next. So this is the code, like a small code. So not that much to do a dry run part by part, but surely let's run this code on a sample test case, and then we will do certain dry runs on the corner cases as well. So for the sample test case, where there are 5 nodes, the target node which we want to delete is having value 2. After deleting 2, which is a non-head node, we are able to delete it, and remaining linkage is 1, 3, 4, 5. But what about having 5 nodes, 1, 2, 3, 4, 5, and we want to delete the head node 1 itself? After deleting head, it should be 2, 3, 4, 5. Let's see if it is able to delete the head node itself or not. So after deleting the head node, what is the remaining linked list? The remaining linked list is 2, 3, 4, 5. So I guess every kind of test case will work. Even if the linked list is empty, it will work. Although the constraint says that minimum there will be 1 node, but we are handling that case as well where there will be 0 nodes. So this is the code. Obviously, you are able to come up to the code on your own, then well and good. If not, then now you can see this code. And one follow-up I want to give as a part of milestone number 5 is, what if you are asked to remove all the occurrences of the target node? And second follow-up can be, if you know recursion, then can you solve this problem using recursion? Can you delete a given node using recursive solution, using recursive function?